Guys, we're back with Matthew Cowley from Spectronics Corporation, continuing the conversation about leak sealants with a little bit of dye conversation in there too. So what you learned on the last one is, yes, one's got a chemical reaction and one doesn't have a chemical reaction. They work differently, and you only know this when you deep dive and you actually apply some testing and some thought and some critical analysis of the product. So let's get back to the conversation. This is the HVAC Know-It-All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. Like, I've used your dye for decades. Like, I remember a post in 2012 that I put out with using it, and that's 13 years ago. But when did Spectronics decide to add a sealant to a dye pack as well? Because you have just straight dye, but then you have the glow seal, which has got both in it, right? Like, when did you make that decision to do that?
You know, the reasoning for, I would say, coming out with our glow seal and maybe being a little bit not on the forefront, like you mentioned the cans earlier. And when I first started with Spectronics, you know, there was the Clip Light brand that had a sealant, and New Calgon had a little bit of that Easy Seal in a can. And then, you know, Spectronics had your dye. And the company always focused on, you know, you need to find it and fix it. You know, a sealant is no different than run flat. There's something wrong with your piece of equipment. You know, how do you actually find it and fix that issue? And that was the fluorescent dye. The sealants, I would say, were more of a market need for us. And like, you know, as you could see, some of the brand exposure maybe on our dye only products have been taken away from some of the products out there that are a polymerizing sealant, which we just talked about are sometimes detrimental to a piece of equipment, and they're adding in that color. Again, I don't really see much of the movement on other products that are dye only. And I think the reasoning for that is Spectronics is going to be oil soluble, whereas all the other dyes are particle-based dyes in the market. And that's the biggest difference. We're a liquid color that is bonded to that host fluid. So it is no added, there's no additional, you know, product in there to keep that together. You know, it's co-solvent free. So you're using a lot less of it because it's very concentrated. You're able to see the brightness a lot better because of it's a non-particle based dye.
I'm going to see if I can pull up my article really quick that I wrote about this, because I fully agree that you shouldn't just blindly add sealants to anything. There's a time and a place, and there's a time, internal HVAC sealants, how to use them effectively. So here's the Coles notes on it. So before considering a sealant product, a proper diagnostic process is essential. Confirm the leak exists. That's one. There's a blurb after that, but I'm just going to hit the main points. Locate the leak. Evaluate repair options. Number 3, confirm a leak exists. So 1, you could walk up to a system and it could look like there's a leak, but it could be a plug dryer, it could be a plug TX or a malfunctioning TX valve. So we have to figure out if it's actually short of refrigerant. Okay. That's the first thing. Locate the leak. This is where I get super frustrated when people say, now it's time to pull out all the refrigerant and pressurize it with nitrogen and start soaping everything. Well, guys, it's already got refrigerant in it. Pull out a good solid leak detector and go at it, because you'll find it very, very quickly if you're doing it right. So find out where the leak is. So let's say you go through the entire unit and you find a leak that is on a braze joint and it's bubbling up real nice after you throw some soap on it. Well, guess what? You're going to recover the refrigerant and you're going to braze that up, pressurize it, pull a vacuum, charge it back up. Now, the problem with nitrogen is that if the leak is in the evaporator and it's tiny and microscopic, those bubbles will not find it. Okay, it will not find it. You could have it under a pressure test for 2 hours and it's not going to budge because it's so tiny that it takes months for it to start showing that there's even, the leak is even there. So go around with your leak detector and find out where that leak is. If it's repairable, repair it. If it's an evaporator that's corroded and your leak detector is going off in certain spots, or it's going off when you just stick it in the evaporator section and you spray it with some soap and there's no bubble showing, well, your leak detector is not lying to you. It's telling you that the evaporator is starting to corrode The walls of the copper are starting to thin and you're starting to get micro leaks. This is a replacement issue. This is not a repair issue. You're not going to start cutting into fins and brazing up these tiny little holes that you can't see, because you're going to cause damage everywhere. This is a replacement issue. So yes, quote, maybe a whole new system. Maybe it's just an evaporator. But the problem is they're not always in front of you. Sometimes they're in a ceiling. Sometimes you have to coordinate. You have to order. You have to quote. And it could be 2-3 weeks, depending on who's in charge of this, to get this job done. Not everything is a straight wham bam job. This is the reality of the situation. So evaluate repair options. We kind of talked about that. So if you can fix it, fix it. So the sealant comes in if it's microscopic evaporator leaks, and you can put it in and charge it up and get the customer going again. And we all know, or we should all know by now if you've tested it, that if the leak is small enough, it will hold up. It will hold up for quite some time, and it will start to coat that leak site very, very quickly within a week or two. And we're not going to lose a ton of refrigerant in that amount of time. We're going to lose mere grams of refrigerant in that amount of time. We're not going to start losing ounces. It's going to be grams. So that's kind of the gist of the article. It's like the dye is the last resort, but make sure you have a leak, find the leak, and then assess your options at that point. So what do you think about those steps, Matt?
You know, like the one part about that is the first one, you know, utilizing a way to actually diagnose the system. And like in the automotive market, you pretty much are attaching a diagnostic tool that gives you a reading. The only real way to understand that, you know, would be to hook your manifolds up. But now, if you go to hook your manifolds up and get readings on the system, you don't know what's already in that product. You know, you don't know what's in that piece of equipment. So you could go to put up your manifold and there already could be some type of product in there that could be problematic to those tools. So again, you know, that first step is always the hardest, because unless it's in a service package from the beginning, so like the same contractor does the install and does the service, so 90% of the time now, a contractor's going to that piece of equipment and not really, or unsure on what he's, you know, there are checks that he could do, but does he really know what's in that equipment anymore? Especially with the use of sealants around you know, across the board. And like you said, there are there's many different types of products that are out there. And a lot of contractors don't do their own research before they use some of those, you know, not safe products.
Yeah. And that's where I really get frustrated. And I'm not angry. I'm just frustrated, because imagine anybody in the world, like you're just sitting there listening to this. Imagine you spent 5 years learning something really, really well, and you knew it like the back of your hand. And then you went out and started telling people about it, and they called you a fool or a hack or an idiot. And they have not spent an ounce of time understanding the modern day situation. Well, it can get super frustrating, right? I mean, I coach soccer, as we talked about earlier. I'm wearing one of the sweaters that I wear. And I've spent a lot of my own time and money taking courses and bettering myself as a coach. And if somebody was in a conversation with me that's never played the game and started telling me how the game works, I'd be like, wait a minute here. I mean, no. Like, it's involve yourself in the game for a bit and then come back to me when you have some experience, and then we can talk. Just blurting things out that don't make sense, right? Or are untrue, or is an assumption, or I like to call the guys on Facebook, they got a fake crystal ball in front of them, and they know what's going to happen as soon as I post it. Oh, you're going to have a dead compressor in a week. I'm like, so what happened to the compressor 8 years ago? It's still running. It's not dead. So tell me about that one. So these are the kinds of things that frustrate me. So yes, in order for you to understand today the modern day sealants, the oil-based stuff, you really have to research. You have to speak to people like yourself, test it yourself, and see what the outcome is, right? You're not going to know this unless you go down that rabbit hole. You can listen to us talk all day, take our word for it, but I don't suggest you just fully take our word for it. Maybe 50% there. Go out and test it yourself and see what happens, and use it in the right scenario. And I guarantee you, if you use it in the right scenario and you follow those steps that I outlined from the article, you're going to have some luck or some success.
And I feel like for the last year, maybe 2 years, we really focused on, conversations like this with yourself. And anytime we've, been on podcast or, dealt with, contractors that, maybe we're going to say social media-esque, but there's never any problems with our product. Anytime somebody tests or utilizes or does their own research, like you just kind of mentioned, to think that they're going to come to the conclusion that Spectronics causes system failures, it's just not possible. The company, it's out there, it's our 70th anniversary this year. So most people that are questioning, the dye or sealant that's in there don't realize that this company's been in business for longer than most people have been alive that are contractors. So like if there were issues, not only that, we worked with these compressor manufacturers, like you mentioned earlier, with the Copen approval. We, on the forefront years ago, we were involved with all of those, compressor manufacturers regarding compatibility testing. Has the model number changed on the approval or what was used from 30, 40 years ago? Of course. But, the system, the way the loop of an HVAC system is the same as it is now as it was years ago. So, maybe refrigerants have changed and oils have changed, but, in the end, leak detection has been very similar. And again, Spectronics has been doing it from the beginning.
Let's talk about how to inject it. There's different ways to inject, but I actually really like your corkscrew method. I used it last week, and that has that yellow hose that's got like a check valve in it, and then it's got the cork. Then you put the cartridge and then the corkscrew. And I was like, okay, let's try this out. So yellow hose, put it on there, then the cartridge, then the corkscrew, and it went in so easily, like just like almost no effort. And then when I'm attaching that yellow hose, I'm waiting to get just a psh, like something, psh, nothing came out. And even in my video, I showed that there was zero dye on the machine. So it's basically a messless procedure to put it in. So talk about that for me, if you don't mind that.
Yeah, as you talked about some competitors out there, it is the only different injection system that we see on the market. Everyone else is a direct inject, whether it's in a little tube or in looks like a spun dryer, like the Rector Seal product, or, in the little direct inject tubes. They're all some type of product that needs to have system pressure or the refrigerant can or the manifolds or something to help flush in that product. And there's usually additional additives in there that help propel that product in there. Where again, if you're using our EZ-Ject method, I remember I used it the first time I used it, and I said exactly what you said to my boss. And I was like, this method is so easy. And he was like, well, why do you think they called it the EZ-Ject? Because like, I'm not nowhere near as technical as you are, and I can install that as easy as you just explained it.
Oh yeah, a monkey could put that in.
Agreed.
Yeah.
And we actually even have a mini version of that for the automotive market.
Oh, okay.
Like
cool.
It's called the mini-Ject. Same concept that it's just a way to also, on the dye only side, you're actually dosing the system. So, if you're using our glow seal, you use the entire cartridge, and that's because you have a sealant and dye in there. But if we're talking about strictly dye with the EZ-Ject method, you're using one line per ton. It's 1 milliliter of our dye for a ton of equipment. So you're completely admissible. You're adding in 3 milliliters of dye to a 12 ounces of oil. It's not going to change any of those components or properties of that host fluid. It's just not possible. You're not installing enough of our chemical because of how concentrated it is. And that goes along with the sealant as well. You're not adding enough of our product because it is concentrated to really mess with any of the properties of the original fluids that are in there.
So the argument could be then, it's a mess when contractors put their their hoses on or their probes on and they take them off. Well, there's devices out there now that don't allow any blowback from your hose or your probes. There's like check valves you can attach your probes to, then attach them to the equipment. Ball valves, yes, but the problem with ball valve on a hose is there's that tiny little bit after the ball valve that's going to have refrigerant in it. But there are devices out there that when you dislodge your hoses or probes from the system, you're not getting any blowback. And that's a safety thing too, because anybody knows that have taken hoses off a refrigeration system that don't have any type of device on it, and it's on the liquid side, you can start getting like frostbite. Like you can get burnt from that liquid refrigerant as it's boiling off and hitting your skin. So I would recommend anybody use something like that along those lines. Is there anything else we can talk about as far as misconception of a leak? I know we got on a podcast and we talked about dye a couple times, but is there any misconceptions on the leak sealant side that you think is important to talk about?
Misconceptions. I mean, I would say again that it's similar to the dye. That number one statement that adding something foreign to a system is detrimental. But again, like you'd said it from the beginning, if you're doing your own research and like if you really wanted to get into it, our products are, again, what the host fluid is, and you're not adding enough into it. So you really need to understand what product you're using out there, because there's a wide range of injection methods. There's a wide range of, where the leak sealant market is an oversaturated market, that a lot of these manufacturers that are coming out with a sealant aren't actually manufacturing the chemical. So you don't really even have the ability to understand the components, because it's a secondary product for them. Whereas again, the chemists and the team behind the dye and our dyes and sealants are, that's all we do. So again, it's more of an understanding of the product. And again, anyone that, when you hear that first reaction that, I've never used it right off the bat. Again, it's like we just talked about earlier. The problem is that he's just being very short-sighted and not seeing the bigger picture, where, you technically shouldn't be including a preventative maintenance product. I mean, that the cost of refrigerant's gone up, the new EPA laws, the idea of not using a type of leak prevention product, or, having some type of preventative maintenance program with your contracting service packages just doesn't make sense anymore.
So in Canada here, the federal buildings need to be annually leak checked. So when I worked for another contractor before I worked for myself, we had some federal buildings. So you have to go once a year and leak check. So it's amazing the amount of equipment out there that's leaking. So let me bring that one step further. I believe it's written in the, I don't know if it's the Ministry of Environment. I can't remember. So don't quote me on who wrote this, but it's from the government, that if a system is leaking in Canada, basically you can't charge it. You can't put refrigerant in it. You have to isolate that piece of equipment, pull the refrigerant out, so on and so forth. But here's the thing. Once you start leak checking things on an annual basis that no one's calling you about, like you just pop up on a roof and there's 40 rooftops up there, 10% of them are going to have refrigerant leaks in the evaporator or somewhere that your detector is going to pick up. But it's still cooling. No one's called about it. So what are you going to do in that scenario? Are you going to go and shut off 10% of the rooftops on that roof and tell people you have to remove the refrigerant until you fix or replace the evaporator coil? You'd be out of business in a second if you did that. So it's just one of those things. It's really tough, because some of the, I know the EPA in the United States is a little bit more lenient when it comes to that stuff, I believe. Like I'm not in the US and I don't know all the stuff with the EPA, but I think they allow a little bit of leniency there, where in Canada it's like, yeah, shut it down, recover the refrigerant. But again, I said, if you're going up to machines that see a small bit of oil in certain places and your detector goes off, but there's actually no problems with that machine that the customer is even noticing, what are you going to do? Shut them off and recover all the refrigerant out of it? No, because it's, again, you'd be out of business, right? I don't know. It's one of those things that you could debate about forever with certain individuals. So I think that's where a product like a sealant comes into play, because with the way they work nowadays, with the small, tiny leaks, coating that pipe, blocking that leak, or covering the opening from an internal position is actually an option now, because of what I've seen with two different electronic leak detectors. They one of them completely disappeared. One of them dropped from 24, 25 ppm down to 1 ppm and was almost non-existent within a week or two. So it's just something to consider once you get to that point. Like I said, fix it if you can. If you can't, it's in the evaporator. What are you going to do? What are you going to do? You can't just shut somebody down out of nowhere, because you would start losing accounts and business all over the place.
And I think the recent changes in the laws and the newer refrigerants, everyone is maybe refocusing on, ways to not have loss of refrigerant. So like it's bringing maybe these conversations, whereas like you said, in the end, in a couple of years, who knows where the usage will actually be in this market, whether it's going to be, on an OEM basis, or, if it's more even spec'd in as needed for a contracting company to have this type of, or offer some type of preventative maintenance package when they're, involved with their licenses. Like you're going to open a business, you have to include some type of way to prevent the loss of refrigerant. It is an ongoing conversation that I think is getting a little bit more in depth. And I could thank you for that. A lot of the research that you're doing is bringing this, whereas again, we as a company have been saying for years how safe this product is, but we need people in the industry like yourself that actually stand up for, that some of those old statements aren't accurate.
No, they're not. They're completely false to the old statements, and it has to be revisited, because that statement I read you, I think apparently was 2015, but the research up to that point was probably a couple of years. So we could be talking about information that is 12, 13 years old. The industry changes fast, man. Like our code books for gas get updated every 5 years. They do that for a reason, right? So the industry's changing and evolving so quickly that every few years we need to look at things from a different lens, a different perspective, and not just start dismissing everything. And I mean, I'll keep testing, I'll keep trying, and I'll keep putting the information out that I come across. But it has to be a conversation. It can't just be, I disagree because I disagree. It's like, why do you disagree? Show me your testing. Show me what you've learned. Show me your leak detector and what you've picked up and what you haven't. Tell me the units you've put it in and where it's been successful, where it's not. And let's find a place where we can use it in success without killing machines. And I know it doesn't when the not the chemical, but the oil-based formula is used, and not a polymer-based sealant. Anyway, rant over. I'm sure we'll talk again.
Yes,
Matt, but
looking forward to it.
Yeah, we actually have a cup game tonight, so I have to get going to go coach a game. But
Very nice.
Thank you very much. I appreciate the support and the information, and the fact that the company is 70 years old. Come on, guys! Like, you've been in the trade. Even if you've been in the trade for 30 years, there's still 40 years more experience over you within that 70 years in that space. So
yes, sir.
Cool, man.
We appreciate the support.
Yeah, thank you.
Thanks, Gary.
Bye.